All right, so let's move on to example 2.25, which is about measuring the angle formed by two vectors. Okay. So let V be our vector with components 2, 3, 3. And let's find the measure of the angles between the different standard unit vectors. So in part A, we're interested in finding the measure of the angle between B and the I component. All right, so this means that we're taking the vector with component I, right? So what this means is our vector V we know is 2, 3, 3, and our vector I, recall, is the vector with components 1, 0, 0. So when we take the dot product between the two, I'm sorry, that should be V and I. So V dot I divided by the magnitude of V times the magnitude of I. Well, the whole point of a standard normal vector is that this magnitude here is equal to 1. So when we work through this multiplication, the only thing that we're going to get is our x component, because the y and z components, when we multiply, are going to give us 0. So we're going to get 2 divided by the magnitude of v, which is 2 divided by the square root of 2 squared plus 3 squared plus 3 squared, which is equal to 4 plus 9 is 13, plus 9 again is 22, so 2 divided by the square root of 22. So similarly, let's find, so that will give us cosine of the angle. So the angle itself is arc cosine of this angle. So if we were to bother to find it explicitly, I'm actually going to use Desmos to do this. I think it's a pretty nifty tool, especially in this aspect. So I'm interested in arc cosine of 2 divided by the square root of 22. And so this final answer is in radians. So we're getting approximately 1.13 radians. All right, so let's move back then to our text. And so what we have for part B is we're interested in the angle between V and J. So once again, we know that cosine of the angle between them is going to be their dot product divided by the magnitude of their components. Well, once again, J has only one component, and this time it's the middle one. So when I take that dot product with V, my numerator is just going to give us the value of 3, and in my denominator, I'm getting the magnitude of V times, well, the magnitude of J, once again, is just going to be 1. So this is now 3 over the square root of 22, which tells us that our angle, which is equal to arc cosine of this expression, 22, sorry about that, is going to be this 0.87 radians. Whoa, just lost control of my keyboard for a second there. Let's try that again. All right. And then finally, part C asks us to do with V and K, where K has our components 0, 0, 1. So taking a look once again at the expression for V, the K component for V is 3. So we're actually going to get the same thing as what we got in part B, because our components are the same. So I'm curious to see how the text tackled this. So just like us, they got the arc cosine of 2 over root 22, which is 1.13 radians, arc cosine of 3 over root 22, and the arc cosine of 3 over root 22. So they've used different Greek letter notation here, but none of that really means anything. Okay, so let's take a look at the checkpoint, which kind of tackles that same approach. So the checkpoint says, let our vector v have components 3, -5, and 1, and find the measure of the angle between the different directionals once again. So v and I, v and j, and v and k. Let's go ahead and pause here and work on that on your own.